Okay, in 5.4, which is multiple or sum difference formulas, these are the formulas you'll need to know. So it's sine u plus v equals sine u cosine v plus cosine u sine v. Sine u minus v equals sine u cosine v minus cosine u sine v. And then the other two, then we've got cosine u plus v is cosine u cosine v minus sine u sine v. Cosine u minus v equals cosine u cosine v plus sine u sine v. If you notice the difference with these two, sine, whenever you add them, it goes sine cosine and then plus. Whatever this plus is, it will be plus here, but it switches between sine cosine and then cosine sine for u and v. Negative, negative. When you go to cosine though, it's always cosine first of u and v, and then you flip the sign. See, this one's plus, this one goes to the negative, so make sure you guys flip the sign on that one. And same thing with cosine, it's always negative. Then tangent, tangent's kind of a pain, but it's tangent u plus v equals tangent u plus tangent v, plus stays the same on the top, then 1 minus tangent u times tangent v. A lot of students get this mixed up on the bottom, so. And then tangent u minus v equals tan u minus tan v over 1 plus tan u tan v. So for tangent, the fractions, the top and bottom changes. So may want to take a minute, pause it, to write those down, and we'll do some examples. Okay, so the first example I'm going to do is to show why it's important that we don't distribute our numbers through. So in our class it's at number 7, but we have cosine parentheses pi over 4 plus pi over 3, and that's our A, and our B, because it's a two-part problem, and they do this one to show the difference So they do this problem to show the difference between the two. So you make sure you don't distribute our cosine in this parentheses. Because this is cosine pi over 4 plus pi over 3, good habit to start out with is label this one u, this one v. So write it out. We have cosine of pi over 4 times cosine pi over 3 minus, because the plus there, okay, sine pi over 4 sine pi over 3. Now, don't just leave it like that. What you need to do is use your unit circle, because these are values. Cosine is x, sine is y. And just plug them in. So cosine pi over 4, that's square root of 2 over 2. Cosine pi over 3 is 1/2. Pi over 4, sine pi over 4 is square root of 2 over 2, then times square root of 3 over 6. Or sorry, square root of 3 over 2. It's multiplication, so make sure with fractions you just multiply straight across. So we get square root of 2 over 4, so multiply top and bottom, both of them, minus square root of 6 over 4. Remember, with square roots, you just multiply the inside numbers if they're the same. So we get this, which turns into over that. That's one way to write it. The other way to write it, which if you want, you can take it one step further. Both answers are acceptable because they are the same thing. Now, sorry. So this is the answer. Both of these, one of these, whichever one you choose, is the answer to this one. Now let's show what this one would be. Cosine pi over 4 is square root of 2 over 2 plus 1/2. That's cosine pi over 3. That equals square root of 2 plus 1 over 2. As you see, totally different answers. So therefore we have to be careful we don't just distribute that cosine with the parentheses. It's kind of different with order of operations. You have to remember cosine is like a function in a term. So there's an example of two, why they're different. So that's pretty simple. We have a complicated one. Which is so that's what we have for this problem. It wants us to find the value, the exact same values of sine, cosine, and tangent of this angle. The book is nice, our book is nice, and for a couple of them it gives us the fraction. For some of them it doesn't give the fraction, so you have to think about what numbers to add on the unit circle to make them happen. So if I start out, label this one u, it's a plus v. So that tells you you're going to use sine u plus v. So just go through the whole process again. So this one is sine u cosine v plus cosine u sine v. All right. Plug them in, so we get sine 3 pi over 4, then cosine pi over 6. All right, and then plus cosine 3 pi over 4 and sine pi over 6. Again, these numbers are on your unit circle, so just plug them in as what you know them to be. Sine 3 pi over 4 square root of 2 over 2 times cosine pi over 6 is square root of 3 over 2. Plus cosine 3 pi over 4, that's going to make sure it's a negative square root of 2 over 2. And then this one's going to be 1/2 sine pi over 6. Multiply straight across like we did previously. We get square root of 6 over 4 minus the square root of 2 over 4. Combine them. That's square root of 6 minus square root of 2 over 4. And that's the answer to sine. We also needed the cosine one. So when we do that, just do the same thing that we did previously. You get cosine u plus v, so that's cosine u cosine v minus, remember you flip the sign with the cosine, sine u sine v. So let's plug in our numbers again. Again, we're using these exact same values over here. So cosine 3 pi over 4, cosine pi over 6, minus sine 3 pi over 4, sine pi over 6. Again, we already have those values because they're on the unit circle. So, plug in what we have. Square root of 2. We get that. Combine our like terms again. And that's what you get for your final answer. You notice they're very similar, except the negative is different. That's going to happen with most of these cases. As one of my students pointed out, she could probably just guess, and she's right. You most likely want to get good at it, guessing exactly what's going to happen. So there's cosine and sine. Those are the easiest of the three. Tangent is the one that takes up the longest room. So just leave that one for a second. Now tan u plus v equals tan u plus tan v. Same side, positive goes on top. Make sure that's a v. 1 minus tan u tan v. So that's what we get there. Tangent, plug in what you have on your unit circle. Again, all my students, I told them to, or hopefully they should have, you guys should have the unit circle numbers on the outline. So we get tan 3 pi over 4 plus tan pi over 6, 1 minus tan 3 pi over 4 times tan pi over 6. As you can see, it's already kind of a mess. It's not too bad though. It shouldn't be too bad because now we're just dealing with numbers. Send your tangent of 3 pi over 4 is just -1. So let's actually come up here. -1 plus pi over 6. Sorry, I don't have my thing. Tan pi over 6 is square root of 3 over 3. All over 1 minus -1 square root of 3 over 3. This is where students get confused. Don't just add those. Make sure you multiply those out. So we get -1. And actually, I'm going to go ahead and skip a step. Make them the common denominator in the top. So that's going to be -3 over 3 plus square root of 3 over 3 all over. This turns into just positive square root of 3 over 3. So 3 over 3 plus square root of 3 over 3. Which ends up being -3 plus square root of 3 over 3 all over 3 plus square root of 3 over 3. This is a complex fraction, very easy to simplify. Hopefully we should be, we're good at it by now, to where these two go in, multiply on the bottom, do not distribute. The 3's cancel. This does not cancel because they're not the same thing. So we have -3 plus square root of 3 over 3 plus square root of 3. We don't like the square root of 3 on the bottom. We multiply by its perfect square factor. So we multiply top and bottom, 3 minus square root of 3. Again, I kind of call it the conjugate. You know, that's one of the terms that you've seen before with imaginary numbers. So I multiply by that. This is a perfect square. That's what we want on the bottom. So we end up getting, just on the bottom, 3 times 3, which is 9. Our middle term cancels out with the perfect square, so we get these, which is -3. And then the top, let's go ahead and factor that out. We get -9 plus 3 square root of 3 plus another 3 square root of 3. Which minus 3. So that's what we get on the top. We can combine these. They have the same square root of 3, we can combine them. When we add them, we only add the numbers in front. So this all ends up being negative 12 plus 6 square root of 3 all over 6. Go ahead and reduce that down though, because the 6 goes, because it's by itself, 6 goes to the negative 12, goes to the 6 as well. So we get negative 2 plus square root of 3 as our final answer for that one. Tangent is the longest one, it takes the most time, but it's not too bad if you just do it with numbers, because it's just basic math at that point. So let me see other ones I kind of want to do for you, so you guys see what's going on. Another example, got at least 2 more examples that we can go over. So this one kind of threw some of my students for a loop. You have to go backwards, because cosine, or sine, pi over 12 is not an answer. Pi over 4, of course, is. Pi over 12 is not. So we kind of need to figure out, then it says, find the exact value of the expression, go backwards. You realize this is a sine, cosine, and it's a plus. The only one of our 6 equations that does that is sine u plus v. So this is your u, and this is your v, as you can see, u and v. So we've got sine pi over 12 plus pi over 4. If I expand this out, it would equal that. If you can't, go ahead and add those real quick. Let's just see what we get. And it's a fraction, so this needs to become pi over 12 plus, multiply top and bottom by 3 because we want it to be 12. 3 pi over 12. I think I did that right, yeah. Add those up, we get 4 pi over 12, which reduces down, let's make sure I get the right answer here, yeah, reduces down to pi over 3. So therefore this all equals pi over 3, so there we get, plug that in, sine pi over 3 equals square root of 3 over 2. So kind of go backwards with that kind of problem. And I got one more example to show you guys. For this problem, it says find the exact values of the equation on the interval from 0 to 2 pi. So this is what you learned in the previous section, was 5.3, which in our section was just solving trigonometric functions. What we do, we have this, we can't just distribute that. Rewrite this as it's a u plus v again. So sine x cosine pi plus cosine x sine pi minus sine x plus 1 equals 0. Evaluate cosine at pi and sine at pi, which is this is turned into, cosine of pi is -1. Sine of pi is 0. So this whole term cancels. This just turns into negative sine x minus sine x plus 1 equals 0. Add those together. And we get negative 2 sine x plus 1. Solve it now. So that means get sine of x by itself. If I solve it real quick, I get 1/2. So when on the unit circle does sine x equal 1/2? And that one, it's pretty easy. Pi over 6. And 5 pi over 6. And because there's no because it's between the interval 0 to 2 pi, that's our only answers we get. That's pretty much it for 5-4, which is sum of difference formulas.